Professor V.K. Patel. I welcome you to my video classes on basic electronics. Today we are going to discuss about an important bit of the basic electronics subject. This is module 3 of your subject and the title of this module is operational amplifiers. Today we are going to discuss about the operational amplifiers. In this module we will discuss the introduction to amplifiers, that is operational amplifiers. Then we will discuss a different op-amp configurations. Op-amp is abbreviation for operational amplifier. Then we are going to discuss about the input modes of op-amp, that is operational amplifier. Then we will discuss about the characteristics of the ideal operational amplifier. A different ideal characteristics. What we are going to discuss are, first one is input offset voltage and current. Next one is output offset voltage. Then we will discuss about open loop gain. Next to that we will discuss about input and output impedance. Next we will discuss the very important parameter called as common mode rejection ratio, most commonly abbreviated as CMRR. And the last characteristics what we are going to discuss is slew rate. We will discuss more about these characteristics later on. Next to this we are going to discuss about the applications of op-amp. Different applications what we are going to discuss are inverting amplifier, non-inverting amplifier, then summer, that is also called as adder circuit. The special case of this adder circuit is also a subtractor. Next to that we will discuss about voltage follower, then differentiator, then integrator, and last one is a comparator. This is what we are going to discuss in module 1, that is operational amplifier. So these are the things which are there for your syllabus. Let us begin with the first bit, that is introduction to the operational amplifier. Before going into the more depth of operational amplifier, let us discuss what we mean by the amplifier. Basically, the amplifier is the circuit which takes a low power input signal and it gives the high power output signal. That is nothing but the amplifier. For example, if I apply the input Vi in between the input terminals, and if let the gain of this amplifier is A, I will get the output Vout in between the output terminals, which is equal to A into Vi. This is nothing but the amplifier circuit. If I apply the input to this circuit, This is what the practical voltage source V1, let us say V1. Then we have an amplifier here in between with the gain A. I'll get the output. Let us assume that the load RL is connected in between the output terminals. I can measure the output voltage in between these two terminals, output terminals, with positive upside, negative downside. In other words, I can say that output voltage is nothing but voltage across the load resistance. Input current, let us denote it as II. Output current, let us say it is IO. Now I can model this amplifier. How to model this amplifier is, I need to identify the resistance in between the input terminals. Let us say input terminals and A and B. I need to look into the input terminals and I need to find out input resistance. Let us call this as Ri. Similarly, I need to identify the resistance in between the output terminals. Let us say these are A dash and B dash. If I find out the resistance between the output terminals A dash and B dash, let us call this as R out. Then I can model this amplifier as, so the input which is applied as it is, V in V1, in series with a resistance Rs. Here Rs is a current limiting resistance which is in series with the input voltage. Then I need to replace this amplifier circuit by Ri, where Ri is basically a Thevenin's equivalent resistance in between the terminals A and B. Similarly, I can model the output side. Output side, again we need to replace it by a dependent voltage source which is equal to A into Vi. Let us say Vi is the voltage in between the terminal A and B, which also we can call it as the Thevenin's equivalent voltage, in series with Ro, which is Thevenin's equivalent resistance in between the A dash and B dash. Then the output resistance or the load resistance Ra. This is what the model of amplifier. Model of amplifier. Now in operational amplifier, how do I can represent operational amplifier? In this model of amplifier, the circuit elements inside this box represents the amplifier. Now operational amplifier, basically it is represented by a triangle. It has two input terminals and one output terminal. Input terminals are marked as plus and minus. An input terminal which is marked by a plus is known as non-inverting input terminal. An input terminal which is marked by a negative sign is known as inverting input terminal. Why these are defined or called as inverting and non-inverting input terminals, we will see later on. So this is the output terminal where I can measure the output with respect to the ground. Input I can apply either simultaneously, that is inverting, non-inverting input voltage I can apply simultaneously, or I can apply separately. And that is why we have two modes of input application. One is single-ended, where I need to apply either input to the non-inverting terminal or I need to apply the input to the inverting terminal. This is the single-ended mode of applying the input. Another mode is double-ended, where I need to apply the both inputs at a time. If I apply the voltage V1 at the inverting terminal, let us say that we apply the input voltage V2 to the inverting terminal. So it has a power supply plus Vs and minus Vs. Majority of the operational amplifiers, they work with two power supplies. It has the positive supply voltage and negative supply voltage. There are certain amplifiers, operational amplifiers, which work on single supply voltage. Now I need to represent this Ri in between these input terminals. This is what the representation of Ri, input resistance or input impedance we can call. Then I need to represent this dependent voltage source and output resistance. This is Ro plus minus A into Vi, where Vi is nothing but the differential input or input between inverting and non-inverting terminals, and we get output. And this is known as abstract symbol. Abstract symbol of an op-amp. Basically, inside the operational amplifier, we have many circuit components. It can have more than 20 to 50 transistors, more number of resistors as well as capacitors. But one can learn operational amplifier without knowing what it is inside the amplifier. And what we are going to do here is, we are not going to bother what it is inside the amplifier. Simply by using this abstract symbol and other parameters of a operational amplifier, we can study the operational amplifiers, and we are going to do that in this model. We will see the next part in next lecture. Thank you.